So let's take it one after the what? Other. By start from what? Where charges on straight line. System of charge on a what? Straight what? Straight line. Like I said earlier that what? The system of charge is the arrangement of charges on a what? On a straight line. So the charges on a straight line, this reverse right here, this reverse to arrangement of charge on a straight line. And it can exist in horizontal or what? Horizontal or vertical form. So the charges on a straight line can be on what? On horizontal form or on what? On a vertical form. If we have what? Charge like this, like positive charge, another charge here is also positive, and we have another charge here, this is what? Negative, call it what? Q1, so charge what? Q1, Q2, Q3. These are the what? System of charge on a what? On a straight what? Straight line. But the charge can also exist in what? In this form. You can have charge here as a positive. We have another charge here as negative. You can also have another charge here as a what? Positive. So this kind of what? Of charge, this one is in the vertical, this one is what? In horizontal. So the system of charge can be in horizontal form, can be in what? In vertical form. So this kind of what? Of system of charge, this one is called what? Or what? Horizontal system of charge. This kind of this that form a right angle with each other, this is what? Right angle with each other is called what? Vertical and what? And what? Horizontal system of what? Of charge. So let us look at what? How are we going to determine the what? The net force on system of charge what? On horizontal what? Horizontal form. So yeah, example one. Example, we say determine the net force on charge on plus 2 microcoulomb charge in the system below. Let's look at it. So here we have positive charge 2 microcoulomb. Here we have what? Call it 4 microcoulomb negative charge. And here we have what? 3 positive microcoulomb. And distance between this side, this is 0.2 meter. Distance between here and here, let's call it what? 0.3 what? Meter. We are now asked to find the what? The net force on charge what? Plus 2. So in this case, you write what? What? Solution. What is solution? The first thing that we do is what? We need to redraw the diagram. Let me redraw this diagram. We have it in this form. Plus, we have charge in the middle, negative. The large charge is what? Positive. They call this one what? Microcoulomb. The distance there is 0.2 meter. The charge here is minus 4 coulomb. The distance there is what? Is 0.3 meter. The third charge is 3 microcoulomb. We are now asked to find the what? The net force on charge what? Plus 2. Back to the what? The example I use here. If you are to find the net force on charge what? Q1, which is what? This. You cannot relabel your this. You can call this one Q what? Q1. Let me put it here. You can call this one what? Q what? Q1, Q2, Q3, because this is origin. It started from here. So to know the what? The resultant force on plus 2. So the plus 2 is stationary. So we now, first of all, if we are asked to solve this kind of question like this, you will follow 3 steps. The first one is what? You obtain the individual forces. After obtaining the individual forces, the second step is what? You will draw the vector diagram. The third step is what? Find the resultant force. You follow what? These steps. What is the first step? Step what? Step 1. Obtain individual force. The first one said what? Obtain individual what? Force. We have how many charge here? 3. But this one is what? Is stationary. But it's the one that we want to check the net force on. So definitely now we need to consider what? These 2 charge, Q2 and Q3. You will now find the force on Q of Q2. The force is between Q2 and Q1, and the force is between what? Q1 and what? And Q3. The first one is what? Let's start with what? The force that exists between what? F1 and Q2. The Q2, the force that the Q2 exact on what? On Q1, it will be what? From Coulomb's law, K Q1 and Q2, everything over what? R squared. This is the formula. So by applying this formula now, the force Here, it will be what? This k is 9 times 10 raised to the power what? 9 into what? Q1. What is my Q1? 2 times 10 raised to the power minus 6. This microcoulomb is what? 10 raised to the power what? Minus 6. That's charge Q1. What is charge Q2? It will be what? You neglected the what? This minus you have here. So you now have what? 4 multiplied by 10 raised to the power minus 6 again. Everything over what? What is the distance apart between charge Q1 and Q2? It is 0.2, everything in meter square. So by pressing the what? The calculator, you will have 2 times 4 will give us what? 8. 8 multiplied by what? 9, we have what? Press the calculator, we have 9 multiplied by 8, that's 72. So here we have what? The force, this will be 72. This added together, 12 plus 9. We have what? 12 minus 9. What times 10 raised to the power minus what? 3. Then 0.24 to give us what? 0. What? 0.2. Everything what? Square. We have 0.04. So divide it. Have 72 divided by what? 0.04. So you have what? You have the final answer what? 1800 times 10 raised to the power minus what? 3 Newton. That is what? The force. Or let's say between Q1 and what? And Q2. So the next thing is what? Let us find the what? The second force. Find the second what? Force. To find the second force, what we do now? We will apply the principle. We're using what? Second force. What do we use? We use F what? F is between Q1 and Q3, second force. We have made it between what? Q1 and Q2 is this. So that Q1 and Q3, which one? Q1, Q3, it will be what? K, Q1, Q2 over what? R square. R of 3 square, abi? So by applying the what? This is to it direct. What is K stand for? Is 9 times 10 raised to the power what? 6. Q1 is what? Is it as what? 2 times what? 10 raised to the power minus 6. And here we have what? 3 times 10 raised to the power what? Minus 6. Everything over what? What is the distance between? Yes, look at this side. Q1 and a Q3. The distance between Q1 and Q3 is what? Sum of what? Oh, 0.2 and 0. What? 0.5, 0.3 add it together because distance between Q1 and the Q3. We will sum these two together. By summing it together, we have what? Is 0.5. Hope this thing is clear now. Distance between Q1 and Q3. Look at the example I give here. I said from here to here, R3. But this time around now, we don't give it like that. We give it separately. So you now sum the two together to have what? 5, 0.5. Abi? So by pressing the what? The calculator, what is the answer for this? Times what? 2 multiplied by what? 3. We have 4. So here we have what? This is 9. We have force of 3 to give us what? 54 times 10 raised to the power minus 3. Everything over what? We have 0.25. That will be what? 54 divided by what? 0.25. It will give us what? So we have 216 times 10 raised to the power what? Minus 3 what? Newton. This is what? The force for, this is the force for what? For the second force. So the second rules or the second step, you know, the first steps are what? Obtain the force or obtain individual force. We have get force between what? Q1 and Q2. Abi? Because and we have get what? Force for what? Q1 and Q3. Because we are target is what? To find the net force on the what? Q1. So the Q1 will be stationary and then you vary the what? The other. So we have get what? The individual forces. The second step now states that what? Step 2, step what? 2, so that what? Redraw. The what? Redraw the vector diagram. If we draw the what? A vector diagram. What vector diagram we have? This is it. We have Q what? Plus Q. We have negative charge. We have positive charge. Which is what? 2 microcoulomb minus 4 microcoulomb. We have 3 microcoulomb. Good. Microcoulomb. The distance apart here is 0.2 meter. Distance apart here is 0.3 meter. Abi? Yes, we are now asked what? To redraw the what? Vector diagram. Excuse me, sorry. So, vector diagram for force that exist between Q1 and Q2. We have negative here, we have positive here. What will happen there? Are they attract or repel? They will what? They will repel. When they repel, the what? The force on this Q1 will move like this. Abi? So it will happen here now. The when they repel, the force we have here, it will what? Going like this. This force represents what? For F1 and 2 between Q1 and what? Q2. But what happened to the what? The force that exists between Q1 and the Q3? Sorry. This is not repel. Oh. This is positive and negative. It attracts. It will come like this. We have it what? F1, F2. So between what? This Q1 and Q3, both of them are the charge of the same kind. They are positive. So this one can never move toward the positive. Why? Because they are the same kind. They will repel. Instead of going like this, it will what? It will go like this. You now have what? The force of 1, 3. It will what? It will repel. So why is it that what? This force F1, F2, yeah, is moved toward the what? The Q. Why? Because Q2 is the charge of different kind. It will what? Attract. So the next thing is what? It is step 3. We are done with step 1 now. Step what? Step 3. Say that what? Obtain the net force. Obtain the what? Net force. Which is what? Resultant force. To obtain the net force, you apply what? Principle of superposition. So the net force here, it will be what? By apply it, net force from superposition theorem So the net force here, you say that what this is more than what this, you now have what F of 21 minus the vector form of what F1 3. So the net force will be equal to what 1800 multiplied by 10 raised to the power minus 3 minus 216 times 10 raised to the power what minus 3. By subtracting it together, you have net what net force should be 1.584 Newton. That is how we can determine the what? The system of what? Of charge on a straight line. Let us solve more questions on a system of what? Of charge on a straight line. Example 2. Calculate the net force on 2 microcoulomb charge on the system below. Look at the system. We have minus 1 microcoulomb. Here we have plus 2 microcoulomb. Here we have plus 5 microcoulomb. Distance between here is 10 centimeter. Distance here is 5 centimeter. Good. Then calculate. I have to calculate this. So this is the question, number 2. We are given to calculate the net force on 2 microcoulomb charge on the system below. This is the system. So where is the 2? Is this. The first thing I said you will do is what? Solution. Solution. After the solution, the next thing that we do is this. What is step 1? Step what? Step 1. State that what? Obtain the individual force. Before you obtain the individual force, please don't forget that what? Rename this. Call this one what? Q1, Q2. This is what? Q3. But our target charge here is Q2. We have to find the what? The net force on this. By doing that, to obtain the individual force, what we do first? We have force. This is the Q2, Abi. The force that experienced between this Q2 and the what? Q1. Q2 and Q1. Why is that what? I write Q2, F2, F, force 2, 1. Because the 2 is our target force. It's our force that we want to know the what? The net force. It's a stationary charge. That's how we write it first. And the is Q1, the force in which the Q1 exerted on what? On 2. And the 2 come first. So you now use what? K Q1 Q2 over what? The distance there. Square. So by doing that, what is the what? The force for this Q1. Say what? F21 The K is what? 9 times 10 raised to the power what? 9 into what? Q1 is 1, neglect the minus, times 10 raised to the power minus 6. Where do I see this minus 6? Is this micro? The one micro here means what? 6, 10 raised to the power minus 6. Into what? The charge of Q2 is 2 into 10 times 10 raised to the power minus 6. Everything into the what? Convert this 10 into what? Into meter. Divide by 100. 10 centimeter to 100, it give you what? It will give us, no mistake, divide by 100. It will give us, am I right? And the 100 is 0.01 square. Good. So by solve this further, 2, 1, this, 2 times this, we have 2. Goes to power what? Minus 12, 9. 2 times 9, 18. 18 divided by 0.1, we are end up with what? 1.8 Newton. That is what? The force charge Q1 exact on what? On Q what? Q2. So the next thing is what? Let us look at what? This is our target force. Abi? We have considered the what? The force between Q1, Q2 and Q1. Good. Which is this? Let us the force between what? Q2 and Q3. And for the second one, what force between what? Q2 and what? Q3. We have force between Q2 and Q3. Notice we are looking for what? This 2. 2 force and what? 3. It should be what? K Q2 Q3 over what? R square. Substitute we have what? F23 Q. K1 is what? 9 times 10 raised to the power what? 9 into what? What is the Q2? Q2 is 2 times 10 raised to the power minus 6. Q3 is what? 5 times 10 raised to the power minus what? 6. Yes, everything over what? What is the distance between minus 1 and plus 5? Q what? Q2 and what? And Q3. Check it here. It's here. It's supposed to be 15. The distance is what? Is 15. Between Q2 and Q3 is what? Is 15. Don't mind my diagram. Oh. This distance is supposed to be more than this 10. So don't mind my diagram, please. So it's 15. So if the distance between what? The charge Q2 and Q3 is 15, by converting this 15 into what? Into, what will I call it? Into meter. It will give us what? 0.015 square. So by pairing this, we now have what? F23, 9 times 9 multiplied by 2 multiplied by 5, 10, it will give us 90. Yes, 90. We have what? 90 times 10 raised to the power minus 3. Everything is 0.015 square. By putting square on this one, we have what? Is 0.0255. So press the calculator. The 90 times 10 raised to the power minus 3 divided by what? 0.0255. If I'm not mistaken, it's supposed to give us what? 400 Newton. So this is what? The first force between what? Of 2, 1, 2 charge 2 and 1, and charge 2 and what? And 3. So the next thing is what? If you follow the what? The procedure, we say that what? After draw the what? After find the force of individual, what is the second what? The second step. The second step says that what? Step what? Step 2. That's the vector diagram. We draw the vector what? Diagram. Let us redraw the vector diagram. By redrawing the vector diagram, we have it in this form. We have what? Minus 1 microcoulomb. We have what? Plus 2 microcoulomb. Here we have what? Plus 5 microcoulomb. Abi now, the distance there is 10 centimeter. The distance there is 15 centimeter. Good. What else again do we need here? Is we need to redraw the what? The vector diagram. Yes. Our target force here is what? Charge plus 2. We have to find the net force on this. So which kind of force occur between the minus 1 and the plus 2? Is this what? Repulsion or attraction? Are they going to attract or repel? This plus 2 will always go to the negative. They will attract. If that be the case, so the force here between the 1 and 2 is what? Attraction. This is what? The force will go like this. F what? 2, 1. This one, it will go like this. But for the what? Between the charge Q2 and Q3, this charge and this one, you know, this is what? Q1, this is Q2, this is what? Q3. So between the what? Q2 and Q3, Q2 is positive charge, Q3 is positive charge. They are charge of the same kind is the most they will repel. So look at what? This Q2 now. Is it going to move toward the Q3? No, they are the same kind. It should move away. As a result, we have the vector diagram for that one. It will be like this too. Is what? F2, 3. Why? Because the Q2 and Q3, they look alike. This Q2 will run away from him. But between what? Q2 and what? Q1 is good. The Q2 will what? Will attract, will move toward the what? The Q1, which is negative. Hope you are getting it now. Here, it attracts. When it attracts, they will go to what? To each other. But here, you cannot go to this side because it's in the same kind, it will repel. It will run away from you. So that's all. This is what? The new vector diagram. The next step is what? Which is step what? Step 3. This said the what? Determine the what? Obtain the net force. To obtain the net force, what we do now? We apply the what? This formula. We say that what? The net force is equal to the what? Force. How many force do we have? 2, 1 plus force of what? 2, 3. So the net force will be what? What is force of 2, 1? We are having what? 1.8 Newton plus 400 Newton. By adding the two together, we have what? The net force will be what? Add it together, it will give us what? If I'm not mistaken, that will be 0.8 Newton. Let me add one more question on this. Example 3. What is the net force on minus 2 microcoulomb charge in the diagram below? What is diagram? As when we have a straight line in this form. We have charge plus 3. We have charge minus 2 microcoulomb. We have another charge, sorry, plus 1 microcoulomb, and we have another charge minus 1 microcoulomb. The distance here is 5 centimeter. Distance here is 10 centimeter. Distance here is also 5 centimeter. Good. Look at this now. It's a system of how many charge? 4 plus 2, 3 minus 2 plus 1 minus 1. So, what is our target force here? That we are required to find what? This is minus 2. So, this is our target force that we are need to find the net force on what? On him. So, the first thing that we do is what? We will write solution. If we write solution, what did the step 1 tell us? The step 1 says that what? Obtain the individual force. If I want to obtain the individual force, what are we do? Look at this diagram. You can help me to rename this as Q what? Q1. This should be what? Q2. This should be what? Q3. This should be what? Q4. So we first of all look at the what? The force that exists between Q1 and Q2. After that, look at what? Q2 and Q3. After that, Q2 and Q4, because you are out to find the net force on what? Minus 2. Sorry, which is Q2. So yeah, for the first force now, look at what? Force, is Q2 against Q1. You know how to write what? Write 2, 1. Yes, is equal to K, Q1, Q2, everything over what? R square. By doing this, the first 2, 1, K is 9 times 10 to the power 9 into bracket what? What is Q1? It's plus 3. We have 3 multiplied by 10 raised to the power minus 6. And what is what? Q2. Neglect the minus. We have 2 times what? 10 raised to the power what? 6. Everything over what? What is the distance apart? Divided by what? By 100. We have what? 0. What? 0.5. We have 0.05 in meter square. This is centimeter divided by 100. You have this 5 centimeter divided by 100 is give you this. So by multiply this 2 times 3 is 6, and then we have what? 6 into what? 6 times 9, then divided by what? Is 0.25. The final answer here is to give you what? 21.6 Newton. If you press your calculator, this is what you are going to want to arrive to for this force. The second one, let us find the what? The second force. The force between what? Q2 and a Q3. So here, let's go. Force between what? 2 and 3. Q2 and Q3, it will be what? K equal to what? Q1, Q2 over what? R squared. That because the force between what? Q2, Q3, K 9 times 10 raised to the power what? 9 into bracket what? Q2 and Q3. What is Q2? It's 2 times 10 raised to the power minus 6. What is Q3? is what? Is 1 times 10 raised to the power what? Minus 6. Everything over what? R square. What is R square? 0.05 square. Press your calculator. By pressing the calculator, we are going to end up to 1.8 Newton. Yes, 2. Yes, 18. This. So force of 2 on this is 1.8 Newton. That is what? The force for this. Yes. So we are done with what? Between Q1 and Q2. Between Q2 and Q3. Good. Abi? The next thing now is what? Between Q2 and Q4. So for this is the final what? Answer. Yeah, let us find for what? Between what? Q what? Q4. Yeah, force of 2 into what? Into 4. Between this and this, what we do now? Here we have K, Q2, Q4 over what? R square. Here you now have the force of this. What is K? 9 times 10 to the power what? 9. Into bracket, the Q2 is what? Is 2 times what? 2 into multiply by 10 to the power what? Minus 6. And the 4 is what? 1. Neglect this one. We have what? 1 in times 10 to the power what? Minus 6. Good. Everything into what? R square. What is R square here? You need to be very add these two together, give you 15. 15 divided by 100 to give us what? 15 divided by 100 will give us what? 0.015. We have 0.015. Everything what? Square. What? Once again, distance between these two and Q4. 10 plus 5. That is the distance. By doing that, if you press your calculator, you have what? 0.8 Newton. The F24 is equal to the what? 0.8 Newton. Yeah, if you follow the what? The procedure. If you follow the what? The procedure. Our next step now is step what? Step 2. Step 2 say that what? Redraw the vector diagram. So to redraw the vector diagram, what we do? Yes, we will redraw the diagram in this form. Don't forget, we have what? What do we have here? Plus 3 microcoulomb. They said this place is what? Is 5. We have minus 2 microcoulomb. And this side is also what? Plus 1 microcoulomb. And the end there is also what? Minus 1 microcoulomb. Good. So they said the distance between this side is 10 centimeter. The distance there is what? 5 centimeter. The distance there is also 5 centimeter. Good. Let us redraw the diagram. We now follow the like charge repel on like charge attract. That's what we follow. If you want to do that now, which one is repel? Which one is what? Is attract. This is our star charge. This is what? We are looking for the what? This. So between these 2 and 3, are they these 2? Is it going to move toward the 3 or move away? Because 3 is positive, 2 is negative. So is a must. These 2 what? Will move a what? Towards the 3. It will attract. So charge what? 2 to 3 will go like this. Good. And the next thing is this. Let us look at what? Between plus 1 and 2. Plus 1 is positive, 2 is negative. Is this 2 going to go to the what? Positive, or we move away? Because it's negative, here we are positive. So it's always go toward the what? Negative charge. So good. Here now, it is the force of what? 2, 3. Force of 2, 3 now is going like this because this is negative, this must go into positive. Like this, good. But in the case of what? This is Q1. Don't forget, this is Q2, this is Q3, this is Q4. Between these 2 and 4, this 4 is negative, 2 is also negative. I said it earlier, that is what it will always move away from this charge of the same kind. If it's charge of opposite side, it will move towards it. So what will happen here? Between Q2 and Q4, the charge of Q2 will move away from what? From 4. You now have what? F2, 4. Good. The next thing is what? This is the new vector diagram. The next thing is what? Step 3. Step 3 said what? Obtain the net force, which is the resultant force. So to obtain the net force, what we do now? The net force is equal to what? How many forces do we have here? 3. These 2 forces, they what? They go to the same direction. You will add them together because they face the same direction. Under total analysis, this face the same direction, add them together. Let's say what? Force 2, 3 plus force 2, 4. They face the same direction. This opposite, you subtract this from them. Force 2, 3. So you now have force. This is equal to the what? 2, 3. What is 2, 3, class? The 2, 3 is 1.8 plus 1.8 Newton plus 2, 4 is what? 0.8 minus force what? Sorry, this one is force 2, 1. I'm not sorry. This one is force 2, 1. Between this 2 and 1. It's 2 what? And 1. Don't mind me, no. 2 and 1. The first charge is 21. 2 and 1 is 2, 1.6. Plus this, 2, 4 is what? Is 0. 2 and 1 is this. 2, 4 is 0.8. Sorry. But 2, 4. What is 2, 4? Where is 2, 4? 2, 3. 2, 3 is minus what? 1 point what? 1.8. So if that be the case, what will be the what? The resultant force. So by pressing the calculator, let me check it. The resultant force 221. Let me remove 8 with 22.6. Yes. No. Remove 1. It's 20.6. We have 20.6 Newton. This is what? The resultant force. But before I will stop from this system of linear charge, I would like to solve a question on it under word what? Word problem. So let us solve this word problem on a system of charge on a straight line. So, solution. To charge -1 microcoulomb and 5 microcoulomb are 25 centimeters apart. First of all, draw the what? The charge. What is the first charge we have here? Is -1 microcoulomb and 5 microcoulomb. What is the distance apart? The distance between them is the distance between them is 25 centimeter. They will now said what if a third charge +2 microcoulomb is placed midway. If the third charge is +2 is placed, don't let me use midway, is placed 10 centimeter away from the origin. From the what? Origin. Then find the resultant force. Help me with that way, please. If what? A third charge +2 microcoulomb is placed 10 centimeter away from the origin, then find the resultant force on -1. So where do we have the what? The third charge 10 meters away. This is 25 abi. You can have what? My 10 meter away here. This is plus what? 2 microcoulomb. So the distance between this and this is 10 centimeter away. If the 10 centimeter away, here we have what? 15 centimeter away. Sum is 25. Yes. You are now asked to find the what? Find the resultant force on -1. Where is the -1? This. So this is our start charge that we need to find the resultant force on. To do that, let us back to the what? To the principle. The step. The first step said that what? Step 1. Obtain the what? Obtain individual force. By doing this, what we do? Obtain the individual force. So let's call this one Q1, Q2, and Q3. So what is the individual force? The force between Q1 and Q2. Have you now? So you now have what? Our first force here is the force F1 on Q2 will be Q1, Q2, R square. You now have what? F1, F2, 9 times 10 raised to the power 9 into bracket. What is Q1? Q1 is 2 times 10 raised to the power what? 9. Sorry, times 10 raised to the power -6. Then, what is the Q? Oh God. Q1. Sorry. Q1 is 1 times 10 raised to the power -6. Q2 is what? 2 times 10 raised to the power -6. Everything into the what? R square. What is this distance there? Divided by 2, it will give us what? Is 0.01 centimeter square. So by pressing the calculator, the force between Q1 and Q2 is supposed to give us what? Is 0.72. 0.72 Newton. So the second one is what? Let us find the force on F2, force on Q1 and Q3. 1, 3 will be Q1, Q3 over what? R square. The force this, what is my K? Don't forget that. What is my K? K is what? Is 9 times 10 raised to power 9. Everything over what? Into Q1 is 1 times 10 raised to power minus 6. Out of Q2 is Q3 is 5 times 10 raised to power minus 6 to all of the distance. Distance between Q1 and this is 0.5, 0.0025 square. By putting the calculator for these two, we have what? Force of 1 3 the 1.8 Newton. Good. According to the what? So this principle, the second step is what? Step 2 said what? Redraw the vector diagram. By redrawing the vector diagram, what are we going to end to? Let us redraw the vector diagram. By redrawing it, we have something like this nature. This is 1 microcoulomb. We have what? Plus 2 microcoulomb. And this side, we have what? Plus 5 microcoulomb. Distance here is 10 centimeter. Distance here is what? 15 centimeter. Have you now? So you can now label this as Q what? Q1, Q2, Q3. Good. So our start charge is what? Is Q1. So to redraw it between Q2 and a Q1, what is the force? This repulsion or attraction. This is negative, this is positive. Automatically, the force supposed to be what? Coming like this. So F1, 2 is moving like this. Between Q1 and Q3, this is what? Negative. This is also what? Positive. Automatically, the what? It will also what? Fade like this, which is what? F1, 3. So by doing this, the next step is what? Obtain your resultant force. Step what? Step 3. So what? Obtain resultant what? Or net force. So to obtain the resultant force, yes, the resultant force here can be what? Now say what? Resultant force or net force. It will be what? Force of what? F21 plus force of what? F13. Add it together, there is net force. It will be what? F12. What is F12 we have here? We have what? 0.72 plus what? 1.8. If we add it together, 7 plus 8 is 15. We have what? The net force should be 2.52. 2.52 Newton. That's the net force for this. So that is all about what? The system of what? Of charge on a linear form. The next thing is what? Let us look at the system of charge on a three factors or in a triangle. So that's the next topic that we are going to treat now. Is yes, a system of what? System of charge on a triangle